Hi everyone, welcome to section 3.3, which is Superfund mixture applications. So at the end of this section, what are our goals? We're going to solve word problems that are using coins, tickets, stamps, and mixtures, and then we're going to use this model to solve problems that deal with simple interest. Okay, super fun. Okay, so first of all, what a coin, right? Let's talk about total value of coins and what that means. Okay, so let's say, for instance, you have, 5 quarters. What's the value of 5 quarters? So right away you would think, oh, okay, it's $1.25. But you can also think of it as, so what did you do to get there? You multiplied the number of quarters times, the amount of the value, right? So the value is 25 cents, which in decimals, you can write it as 0.25. So let's say you have here 14 quarters, 17 dimes, 21 nickels, and 39 pennies. So 14 quarters would be 14 times 0.25, that's $3.50. 17 times 10 cents is $1.70. 21 nickels times 5 cents, notice that 5 is 0.05 or 5 hundredths, which makes sense, right? Because it's, that's how we express money. And then pennies is worth, 1 cent or 1/100th of a dollar. So, and we would add these up to get the total value of all the coins. We would add each, the total value of quarters plus the total value of dimes plus the total value of nickels plus total value of pennies, okay? So let's go ahead. We're going to use this kind of chart thing lots of times. So let's start. Okay, so first of all, before we do another problem, a problem, it's the same thing where how do we solve them? We read the problem, what types of coins are involved. We can create a little fun table, type, number, value, total value. We list the types, the values, and then write the total value. And then we name what we're looking for. We can use expressions to represent the number. And then we translate into an equation and you solve it. You can check and then you can answer it. Okay, so let's say here we have Adalberto has $2.25 in nickels and dimes in his pocket. He has 9 more nickels than dimes. So how many type of each coin does he have? So what are they talking about? They're talking about nickels and dimes, okay? So we have a table. We can just, hover it like something like this. Sometimes I'm not the best at drawing. That's all right. So here, so we have the type. So we have dimes and nickels. So dimes, nickels, and then we have the number or the quantity. So number of, and then times, we're going to multiply that by the value, and then that's going to equal the total value. Okay, so let's see. He has 9 more nickels than dimes. So if dimes, we're going to let dimes be represented by X, then the number of nickels, the number of dimes is going to be X, and then the number of nickels would be 9 more, right? Because he has 9 more nickels than dimes. Okay, so the number, we say this is X and this is X plus 9. The value, of course, it's a dime, that's 10 cents, and this one is 0.05, right? Then we multiply across, so that's going to be 0.10x. This one is going to be 0.05 times the quantity X plus 9, okay? And then the total value is given to us in the problem. So that's $2.25. So basically this plus this is going to equal. So 0.10x plus 0.05 times the quantity X plus 9 is equal to $2.25, okay? So then to simplify, what could we do? We can just go ahead and use distribution property. So we have here, 1/10 x plus, we distribute the 500ths, so you get 500ths times x plus, and then 500ths times 9 is 0.45, and that's going to equal to 225. So then we do like terms. So that's 0.15x plus 0.45, right, or 45 hundredths is equal to $2.25. We subtract both sides by 45 hundredths. Okay, and then we bring this down, so that's going to be 1,500 times x is equal to, it's equal to $1.80. Then divide both sides by that 0.15, right? And you would get x is equal to 12, okay? So that's the number of dimes. So there are 12 dimes. How many nickels are there? So dimes, so there are 12 dimes. And there's 9 more nickels than dimes, so you just add 9 to 12. So the number of nickels, there are 12 plus 9, which is 21 nickels. Okay? All right, let's do another example. Liliana has $2.10 in nickels and quarters in her backpack. She has 12 more nickels and quarters. How many coins of each type does she have? So remember, so again, we're going to have the type. So we have nickels, and then we have quarters. Okay, so then we have the quantity, or the number of, times the value of each is going to equal the total value. Okay, so this, Okay, so let's see. We not 12 more nickels than quarters. So if quarters is x, there's 12 more nickels, x plus 12. And then we know the value of each, right? Nickels, 5 cents, quarters, 25 cents. We multiply across. Okay, and then the total value is $2.10. Okay, so let's go ahead and write that as an equation. So the little chart is super helpful, you know. Right, so we have the total value of nickels plus the total value of quarters is equal to $2.10. So let's go ahead and distribute. Then we're going to do like terms. Okay, and then we're trying to isolate the variable here, so we get $2, right? And then divide by 30. So here we're going to do 2 divided by 30. I mean 0.3 or 30 hundredths, right? Let's see here. So let me make sure I did everything correctly. 2 tenths to 5.30x plus 2. 0.01. Oh, I messed up. I'm so sorry. This is a 12. I don't know why I wrote a 2. Oh, geez. I'm like, why is this? This is not right. Okay, that's fine. That's okay. So we have here 0.05 times 0.12. So 5 cents times 12 is going to be 0.6. That changes things. That's okay. That's going to change this part and this part. I'm so sorry. My bad. Okay, so then 0.6 here. Now we're going to subtract that from both sides. I know. See, I was doing it on purpose to see if you were listening. Were you listening? I'm sure you were. Okay, so that's $1.50. There it goes. That's nice and easy. That's going to give us that whole number that we like. Okay, so 1.5 divided by 0.3 is going to be 5. So that means that she has 5 quarters. So 5 quarters, but she has 12 more nickels. So 5 plus 12 nickels. In other words, 17 nickels. Okay. All right. So here, we're going to use the same concept to do ticket and stamp problems. So the school concert, the total value was 1,506. Student tickets sold for $6 each, and adult tickets sold for $9 each. The number of adult tickets are 5 less than 3 times the amount of student tickets sold. The number of. So we have here quantity times value equal total value. Same thing. We use the same thing, okay? So we have $6 each, $9. So they're giving us student tickets and they're giving us adult tickets, okay? And then they say the number of adult tickets sold was 5 less than 3 times the number of student tickets sold. Okay, so that's kind of, let's take that apart. So the number of adult tickets, so adults, was 5 less than 3 times the number of student tickets. We don't know what the number of students' tickets is. So we let that be X, okay? So we have students, the quantity is X, and then for adults is 3X minus 5. Okay, then we multiply across 6X, 9 times the quantity, 3X minus 5. Together, that's going to be 1,506. So then let's go ahead and write that in a beautiful equation. Minus 5 equal to 1,506. Let's distribute here. 6X plus 27X minus 45 is equal to 1,506. So add 45 to both sides. Okay. We get like terms here. Oops, I did that. It doesn't matter. Honestly, the order is the same. So 6X plus 27, that's going to be 33X is equal to 1,551. Okay, and then divide by 33. And we will get the number of student tickets, right? So that's 47. So if X is 47, that's the number of student tickets. Then the adult, we need to plug it in. So 47 student. But what represents the number of adults? 3X minus 5. So to find adults tickets, we need to plug it into 3. We need to plug in that X minus 5. So 3 times 47, which is 141 minus 5. Okay, so I'll subtract 5, 136. So we have 136 tickets for adults. So 47 students and 136 adult tickets. All right. So let's do a super fun example. The first day of a water polo tournament, the total value of tickets sold was $17,610. One-day passes sold for $20 and tournament passes sold for $30. The number of tournament passes was 37 more than the number of day passes. So how many day passes and how many tournament passes were sold? So again, this is a quantity times value equal total value situation. So what are we have the one-day passes, and then we have the tournament passes, right? Tournament, and we don't know. So we know that the one-day passes are $20 and the tournament passes are $30. Number of the tournament passes, so let's go ahead. This is important here. The number of tournament passes was 37 more than the number of day passes sold. We don't know what the day passes is, so that's X. Okay, so then that's going to be, we're going to let day passes be X. So one day passes is X, tournament passes is X plus 37. To fill in the last one, we multiply across 20X, 30 times the quantity, X plus 37. Now when we add them together, we're going to get the total amount, which is 17,610. So let's go ahead and write that. 20X plus 30 times the quantity X plus 37 is equal to 17,610. Okay, so let's go ahead and simplify this. We get distributing the 30. We get 30X plus, and then what is 37 times 30? 1,110 is equal to 17,610. So combining like terms, we get 50X plus 1,110 is equal to 17,610. So then let's subtract. We're doing commas. So then subtract both sides, we get 50x is equal to, and then this is going to be 16,500. So divide by 50. Okay, and then x is equal to, we get x equal to 16,500 divided by 50. Oh, I hit 16,500 divided by 50 is going to be 330. So that represents what? The number of day passes. So how many tournament passes is going to be 37 more. So day passes. So 330 day passes. And then tournament passes is going to be 330 plus 37. So that's 367 tournament passes. Awesome.